Welcome to the VST Electrical Contractor Training for the installation of the North America version of the Green Machine. We'll be covering how to complete the electrical installation, which you'll find in Chapter 3 of the manual that accompanies the Green Machine. VST recommends that you follow along with this video in your manual. But first, a disclaimer. This video was prepared as a quick review for general contractors, vapor piping contractors, and electricians who are installing the VST North America Green Machine. It is not intended to replace the Installation, Operation, Maintenance, and Troubleshooting Manual, or IOMT manual, provided with the Green Machine. Refer to the IOMT manual for full information and detailed engineering drawings. Starting with safety, remember that a GDF is a Class 1, Division 2 hazardous location. The Green Machine will be installed near locations where highly flammable and explosive gasoline vapors may be present. Installation of the Green Machine must comply with the National Electric Code, federal, state, and local codes, as well as other applicable safety codes. Use extreme caution due to the risk of fire or explosion, which could result in serious injury or even death. If you're working in an area where vehicle traffic may occur, always block off the work area during installation, testing, and service to protect yourself and others. Do not use power tools that can generate sparks if there is a risk of flammable or explosive vapors being present. Read and understand all materials related to installing, testing, and operating the Green Machine prior to installation. Turn to Section 3.1 in the manual to follow along with this information about the general electric installation. All information can be found in the yellow electrical installation packet located inside the manual. This packet includes the electrical installation chapter from the main manual and ledger-size engineering drawings. All wiring must be gasoline and oil resistant, TFFN, or THHN with 600 volts insulation. The electrical contractor is responsible for sizing the wire, cable, and conduit according to the NEC. All facets of the electrical installation must meet the various codes and jurisdictions at the federal, state, and local levels. The Green Machine must be installed in accordance with the NEC, NFPA 70, and NFPA 30. As we start planning the electrical installation, let's look at the necessary components and who is responsible for supplying each of them. There will be several components that exist already at the GDF. These include the main electrical panel, the fuel management system, the overfill alarm relay located within the fuel management system, and the station ESO. VST will supply the control panel, which comes internally pre-wired from the factory. Also internally pre-wired is the Green Machine internal junction box, which sits in the middle of the Green Machine vapor processing unit. The contractor is responsible for supplying an outlet and a disconnect switch, both to be installed next to the Green Machine unit. The contractor is also responsible for all general installation and components, including conduit, wire, cable, fittings, seal-offs, and any other components deemed necessary. The VST control panel does not have punch holes in the bottom, and these holes must be drilled for wire installation. The VST control panel is to be installed inside the GDF data hut. The closer the control panel is to the fuel management system, the better. Now let's turn our attention to the installation instructions listed here. 1. Pulling wires from the data hut to the Green Machine area. 2. The proper way to wire each of the components in the Green Machine system. 3. Proper labeling of the electrical panel. And finally, 4. How the control panel should look at the end of installation. Here is a high-level view of the electrical system involving the Green Machine and its control panel. The dashed line here represents the wall of the GDF data hut. Everything above this line is inside the data hut, while everything below the line is outdoors. There are 7 components within the electrical system. 1 is the VST control panel. The control panel is the center of our electrical system, and it ultimately determines if the Green Machine should power on or off. An important system for the VST control panel to be connected to is the 2. Emergency shutoff, or ESO. This connection ensures that the VST control panel and in turn the green machine will lose power when the ESO is activated. It is also possible to power the VST control panel from the ESO. This situation will be covered later in this video. The next system is 3, the tank gauge system, usually a Veeder-Root TLS 350 or 450. This system is sometimes called the tank sensor or the tank level sensor. In the event of an overfill, this system will send an alert to the VST control panel. The control panel will in turn deactivate the green machine. If the tank sensor system is not correctly connected to the control panel, then the green machine may ingest gasoline, which will ruin the vacuum pump inside. Number 4 is the main electrical panel. The main electrical panel powers the VST control panel on a 20 amp breaker and also powers 5, a 115 volt outlet, which is to be installed outside near the green machine. This outlet will provide the power necessary for any testing and maintenance required to keep the green machine running in good condition. This outlet, along with 6, the safety disconnect switch, should be placed in close proximity to the green machine. The safety disconnect switch, when engaged, will cut power to the green machine. Cutting its power will allow for safe testing and maintenance to be performed on the green machine. Number 7, and finally the green machine itself. The green machine is the vapor processing unit. Before talking about pulling any wires, it is important that you, the electrical contractor, decide how to provide power to this electrical system. There are 2 options for powering the VST control panel. Follow along in section 3.5.2 of the manual. Option 1, from the main electrical distribution panel, or Option 2, from the station emergency shutoff relay. Let's talk about Option 1, specifically about the wiring between the electrical panel and the VST control panel. The size breaker required for this connection is 20 amps. The power wires must be terminated at these locations inside the VST control panel. Label the breaker on which the VST control panel is connected with the name Green Machine in all caps so that a service tech can quickly figure out which breaker it is. Next, for Option 1, we're going to discuss the 2 wires that must be run between the VST control panel and the emergency shutoff, or ESO. The ESO circuit is located inside the hut, inside the power box. The ESO circuit is usually a part of a shunt circuit and must be wired as such. Here's where the wires that run between the VST control panel and the emergency shutoff system are to be terminated. The emergency shutoff relay that is on the other end of the wires is located in the power box inside the GDF or data hut. Here's a picture of the inside of a data hut. Note the VST control panel on the right and the power box on the left. The red dotted line is a potential path the wires can be run along. The ESO circuit to the VST control panel must be installed for it to have power to operate the green machine. It is required that the VST control panel and in turn the green machine lose power when the emergency shutoff system is activated. Note that in Option 1, 3 power wires were pulled from the electrical panel. For Option 2, this connection is unnecessary. For Option 2, we'll be powering the VST control panel directly from the ESO relay. Just like in Option 1, the power wires must be terminated at these locations inside the VST control panel. Recall that in Option 1, the VST control panel needed to be wired to the station ESO so that the control panel and green machine lose power if the ESO system is activated. In Option 2, the VST control panel is powered directly from the ESO. Because of this, a second connection to the ESO is not needed. While the second connection to the ESO is not needed, current still needs to flow between these 2 terminal blocks. Simply install a jumper between these terminal blocks to complete Option 2 of powering the control panel. Now that you've got the wiring correct for powering the VST control panel, let's look at pulling wires from inside the GDF data hut out to the green machine. Follow along in section 3.5.4 of the manual. Recall that in our earlier graphic, the dotted line represents the wall of the data hut. Any wires passing through this dotted line are to be pulled from inside the hut out to the green machine. A total of 12 wires and 1 cable must be pulled. These wires and cable must be pulled through rigid conduit. The first group of wires that need to be pulled is the group of 9 wires and 1 cable from the VST control panel to the Green Machine and safety disconnect switch. Both the Green Machine functional and safety disconnect subsets of wires are to be run through a gang box. These wires should all be pulled through the wiring port, which is the port located second from the left on the outside of the Green Machine. This picture shows the internal junction box on the Green Machine. The wires that are pulled from the VST control panel must be pulled to the internal junction box through the conduit, which is highlighted in red, from the electrical port on the outside of the Green Machine. Of the 4 ports on the exterior of the Green Machine, the electrical port is located second from the left. Here is an interior picture of the Green Machine internal junction box. The wires within the pressure sensor cable and the 6 functional wires must be terminated at the terminal block with the corresponding number identifier. All connections within the red box are on the bottom of the terminal blocks and come pre-wired from VST's production facility. The electrical contractor is only responsible for terminating wires to the top side of each terminal, so do not do anything with the wires at the bottom of the terminal block. This table shows each of the wires and its corresponding identifier. All of the terminal blocks inside the VST control panel and Green Machine internal junction box are labeled with the corresponding wire identifier for easy identification and matching, basically an A to A, B to B matching of wires to terminal blocks. This information is in Chapter 3 of the Green Machine Manual for your quick reference. Take a look at the terminal blocks inside the VST control panel. Highlighted here are the places where each of the 6 wires that are being run to the Green Machine internal junction box are to be terminated. Next are where the wires within the pressure sensor cable are to be terminated in the VST control panel. This cable should be pulled alongside the functional wires to the Green Machine internal junction box. And again, notice the ease in matching wires to the terminal blocks because of the identifiers. The other set of 3 wires that need to be pulled to the Green Machine powers a 115 VAC outlet from the main electrical panel. This outlet is to be installed near the Green Machine and will be used for testing and any maintenance that requires a power source. In a real-life setting, here's what the outlet will look like after it's been installed correctly. Turn to section 3.5.4.3 in the manual for information on the safety disconnect switch. These wires should be pulled out to the gang box, along with the 6 functional wires and pressure sensor cable. The safety disconnect switch wires must be separated from the other wires at the gang box and run to a safety disconnect switch, which is to be installed near the Green Machine. The safety disconnect switch is a safety feature for anyone performing maintenance or testing on the Green Machine. When this switch is tripped, the Green Machine receives no power. Here's an example of a properly installed safety disconnect switch. Notice how it's conveniently installed next to the 115-volt outlet. Finally, we'll discuss the 2 wires that form the connection between the VST control panel and the fuel management system. Follow along in section 3.5.5 of the manual. This connection alerts the VST control panel when an overfill condition exists. Here's where the overfill wires are to be terminated inside the VST control panel. The VST control panel, on the right, must be connected to a 4 relay module within the fuel management system, shown on the left. In this example, the tank monitoring system is a Veeder-Root TLS 350. Once all the wiring is complete, the VST control panel can be turned on by turning the power switch to the on position. The PLC screen on the front of the control panel will have a large red box with the message GM Disabled, enter code. This is by design. The Green Machine cannot and will not run until it has been tested and started up. This is the responsibility of the startup or commissioning contractor. If the smaller box labeled GM status is red and displays alarm as it does here, press the Faults and Alarms button and go to the alarm screen. The active alarm will be highlighted in red, and troubleshooting is available in Chapter 8 of the Green Machine Manual. It is most likely that if an alarm exists at this point, the wiring of one of the components is to blame. If there are no alarms and the Green Machine status is normal, you're ready to finish. Once there are no alarms, make sure that the maintenance switch is still in the on position. When this switch is turned off, it will only cut power to the Green Machine and not the control panel. Pass the carabiner clip through the power switch to lock the power switch in the off position. This clip stops the power switch from being accidentally turned on or turned off. There are some avoidable mistakes that we've observed in past installations. Starting with if the emergency shutoff and/or safety disconnect systems are not wired correctly, or the VST control panel is not connected to the safety disconnect switch. In either case, the VST control panel will receive no power and be unable to power on. If the overfill system is not correctly connected to the VST control panel, then the Green Machine may be turned on in an overfill condition. This activation may result in a damaged vacuum pump and would require replacement of the vacuum pump, causing extended downtime and expense. We have seen the 115-volt outlet powered from the vacuum pump circuit. This could result in two problems. One, insufficient current to the outlet rendering it useless, or two, if the safety switch is engaged, the outlet will receive no power. Remember that the outlet is there to aid in the completion of any testing and maintenance task, so it is important that it is not dependent on the safety disconnect switch for power. We have seen the 20-amp breaker inside the main distribution panel not labeled or labeled incorrectly. If this breaker is not labeled, it can take a technician longer than necessary to complete routine maintenance and testing. Plus, he runs the risk of working in a hot panel. Finally, it is important that the carabiner clip not be missing from the power switch on the front of the VST control panel. This clip helps keep the control panel in its desired mode, whether that is on or off. You have reached the end of this video.